Are you ready for this super stellar, awesome science video? I feel like we should be like telling ghost stories, but we're gonna talk about science instead. So here we go. So hopefully this will help us understand a little bit better how the poles are tilted and how the sun revolves around the earth and why that helps create our seasons. Okay, so here we have our sun, right? Okay, so here's our earth. It is tilted. So right now we can see, it's right, that equator is getting most of the light. This was like up a little more, but it's fine. It's totally fine. I'm making this up as I go, guys. Okay, so here we have this here. So this pole, South Pole, is tilted away. We can see the North Pole is to the sun. So we're here, here's Utah, us. So we're in summer right now because we are tilted toward the sun, okay? So as we travel back here, we can see both of these poles here. So here's our two poles. They're getting equal amounts of sunlight. I'm trying to find that one in there. It's here, I just can't see it very well. Okay, so here's our two poles. They're getting equal amounts of sunlight. So this is spring and fall. So back here we have summer, and then this one's pointed away, we have fall. So notice, right? So the earth is coming around the sun and the tilt is always pointed in the same direction. It doesn't wobble around, okay? So it stays, so notice, right? The North Pole is always going to stay pointed to the north. So here we have spring and fall. We can see both poles sticking out. So as we travel around this way, now we can see the South Pole is pointed toward the sun and the North Pole is going to be in the shadow, okay? So parts of it as it spins around will go into sunlight, but there are certain parts by the poles that during their winter or that never see sunlight, and there's parts that are in summer that will have constant sunlight because even as it turns, it's still seeing the sunlight, and up here is never seeing the sunlight. And there's other parts that will have like 2 hours of night and 22 hours of day because of the tilt of the earth. So now here we have summer, here we have winter. So just it's opposite, right? Over here we had summer on the top, the north, and then winter. And as it travels around, it's pointed in the same direction, right? That tilt line stays the same. But now we have winter in the north and summer in the south. And then it will come in front and you can see both poles evenly from the sun. There's another spring and fall, and then it will come around again, and that's made a year. So that revolution helps it to create those seasons. But right, it also has to be tilted, otherwise everything's just getting the same sunlight that it had at every other place, right? If I'm looking here, it's getting the same sun, same sun, same sun. It's always just getting that same amount of sunlight. Nothing's changing. But once it has a tilt, then sometimes it gets more sun. But when it's been half a year, now it's tilted away and now it's getting less sun, so it'd be winter. So the tilt and the revolutions together cause that unequal heating, and that unequal heating in turn causes our seasons. So it has to be tilted and it has to revolve around the sun to create our seasons. So hopefully that helps you see a little bit better that tilt is staying in that same direction and the sun is staying put and our earth is revolving around the sun, causing different parts of the earth to get more direct or indirect sunlight. So there you go, guys.